Okay, so imagine this. You're a scientist, and you're on the hunt for a specific antibody, right? But it's like you're trying to find, like, a single grain of sand on a beach. Like, talk about a challenge.
It really is. I mean, trying to isolate these tiny, powerful proteins, it's a huge undertaking.
It's a massive undertaking, and that's exactly what we're diving into today.
Yeah, so in this deep dive, we're going to follow a scientist who's using this really cool technique. It's called biopanning. Biopanning. And they're trying to find antibodies against these kind of elusive targets.
Okay.
The JNU and U antigens.
JNU antigens.
Yeah, think of them like rare gems.
Okay.
But they're hiding out on red blood cells.
Ooh, this is sounding intriguing.
Yeah.
So tell me, like, what's the big deal about these JNU and U antigens? Why are they so important?
Well, the JNU antigen, that's a pretty new discovery in science. Actually, so new that we don't really know the full extent of its role yet.
Really?
Yeah. But the U antigen, that's a different story.
Oh.
Most people have it, but a small percentage of people don't.
Right.
And for those individuals, lacking the U antigen can actually cause some serious complications, especially when it comes to things like blood transfusions or even pregnancy.
Wait, so you're saying their bodies attack the U antigen?
Exactly. So if someone who is U negative is exposed to blood that contains the U antigen, their immune system is basically like, whoa, foreign invader.
Right.
And it produces these antibodies to fight it off.
Okay.
And this can cause a reaction that actually destroys those transfused blood cells.
Oh, wow.
Yeah, and then in the case of pregnancy, it can even lead to complications for the baby.
Okay, yeah, that makes finding these antibodies seem even more important now.
Absolutely.
I'm starting to really see why this scientist is so determined to find them.
Oh, yeah.
So how does this biopanning thing work? I mean, it sounds pretty high-tech.
It is, but at its core, it's actually a pretty simple concept. Imagine a giant library, right?
Okay, a library.
But instead of books, it's filled with millions of tiny viruses.
Oh, wow. Millions of viruses.
And each of these viruses, it carries a little piece of a potential antibody on its surface.
So it's like each virus is holding a tiny piece of the puzzle.
Yes.
And our scientist is trying to find the missing pieces that fit the JNU and U antigens.
You got it.
Okay, so how do they find the right pieces then?
So to find the right pieces, the scientist introduces this target that mimics the JNU and U antigens.
Oh, okay.
And the viruses, right, that have the antibody pieces that can bind to these targets, those are the winners. They get to stay while the rest are washed away.
It's like a game of musical chairs for viruses.
Exactly.
Only the ones that find a seat get to stay.
And then they take those winners, right, and they make tons of copies of them, and then they repeat the process several times to make sure that they only have the strongest contenders, the ones that bind to the target really, really well. And in the end, they can actually identify the specific antibody pieces that were displayed by these champion viruses.
So it's like narrowing it down from millions to just a handful of potential pieces.
Right.
That's really amazing, actually.
It's a pretty elegant technique.
Yeah.
So our scientists had a plan. They decided to start by using a lab-made version of the antigens.
Oh, okay.
Sort of a simplified decoy.
Gotcha.
To see if any antibodies would latch on.
So they're going for a more streamlined approach.
Exactly.
It makes sense, especially if you're dealing with something as complex as these antigens.
Right.
So the big question is, did it work? I mean, did they find what they were looking for?
Well, science rarely goes as smoothly as we'd like, right?
Right.
And this initial attempt was kind of a bust.
Oh, no. What happened?
So they did manage to isolate 12 potential antibody fragments through this biopanning process. But when they took those fragments and transformed them into full-fledged antibodies, they just could not bind to the real red blood cells.
So they found something that looked like it should work.
Right.
But it just didn't.
Exactly. Like finding a key that looks like it should fit the lock, but it just won't turn.
Oh, man. That's frustrating. So what did they do? Give up?
Well, that's a great question, and it's one that many scientists face. But our researcher wasn't ready to give up quite yet.
Okay.
They decided to change tactics and try a different approach.
Okay, plan B. I'm intrigued. What'd they do?
So for plan B, they decided to use whole cells.
Hollow cells.
Yeah, whole cells that express the complete molecule where the JNU and U antigens reside.
Okay.
It's called glycophorin B.
Glycophorin B. So instead of just using that simplified decoy, they're using the whole structure where these antigens actually live.
Exactly.
Well,
showing the antibody library, like the full picture, instead of just a zoomed-in section.
Yeah. a much bigger picture.
Exactly. So it was a bold move, but would it pay off?
This is like a real nail biter.
I know.
Did it work?
Well, I hate to be the bearer of bad news.
Don't tell me they struck out again.
Sadly, yes. Despite using this more comprehensive approach, they still couldn't find any antibodies that would reliably bind to those JNU or U antigens on real red blood cells.
Man, after 2 failed attempts, you'd think they'd be ready to throw in the towel.
You would think, right? But our scientists, they were not one to be easily deterred.
Really?
Nope. They had one more trick up their sleeve.
Okay, plan C, this is it. This is the last chance. What did they do?
So for their third attempt, they decided to stick with the lab-made peptide approach,
Okay.
but they went bigger.
Okay.
So they designed a much larger peptide. That encompassed the entire external region of glycophorin B.
So same basic strategy, just supersized.
Precisely.
Yeah.
They were hoping by giving a more complete picture of that target region, they might finally find those antibodies they were looking for.
All right, I gotta know. Did it work?
Well, it was another swing and a miss.
Oh, man, come on.
No, I know.
So even with the bigger peptide, still no dice.
Still no dice. Those antibodies, they just couldn't seem to find the lock, on the real red blood cells.
Man, talk about hitting a brick wall. It's like when I lose my keys, I think I'm looking in the right place, but the whole time they're in my other pocket. Maybe the scientist was looking in the wrong spot for these antibodies.
You might be onto something there. Remember those whole cells from Plan B?
Yeah.
They did actually yield a few possibilities. 4, to be exact.
Okay. So there's some hope.
A little glimmer, but only 3 of them could even identify red blood cells, and even then, just barely.
So it's still pretty faint, huh?
Yeah. And get this, further testing showed that only 2 of those were actually unique antibodies.
Oh, wow.
And even when they developed those into their final, fully functional forms...
It still couldn't do it. They still couldn't identify the JNU and U on the real cells.
They couldn't. Rough, I know.
After all that work. Even though they didn't find the exact antibody, at least they learned something, right?
Oh, absolutely. This research wasn't a waste at all. It revealed something super important about how those antigens might be acting.
Oh, really? Fill me in.
Okay, so the scientist thinks the main reason for these failures is probably that JNU just weren't being presented in the right way to the antibody library during the biopanning.
Oh, so it wasn't the antibodies themselves. It was how the antigens were being shown to them.
You got it. Imagine trying to identify a friend from a blurry photograph.
Yeah.
Doesn't matter how hard you try, you just can't make out the details.
Wow, so they need to find a way to, present those antigens more clearly.
Exactly. They need to make it more natural, like a 3D presentation.
So how do they do that? How do they show it in 3D?
That's where things get really interesting. Now they need to dig deeper into the structure of that glycophorin B, the protein where these antigens live.
Oh, okay. So, they need to make a map.
Exactly. They need to map out that terrain to figure out exactly where those hidden gems are located.
That sounds like a whole other deep dive.
It does, doesn't it? And this really highlights something important about scientific progress.
What's that?
It's not always about those big, splashy discoveries. Sometimes it's those subtle shifts in understanding, like what happened here, that really make all the difference.
So it's like they stumbled onto a secret passageway, and now a whole new area of research is about to open up.
Yeah, a whole new world. And this is where the real potential lies. If they can understand glycophorin B's structure, they could develop even more specific and effective antibodies, not just for JNU, but for all sorts of targets.
Wow, so this research, even though it didn't give them exactly what they wanted, it can still be hugely important down the road.
It really could. It's a reminder that science doesn't always give us the answers we're looking for, but often it leads us to even more fascinating questions.
This whole deep dive, it's been about way more than just these antibodies. It's really been about how science works. The ups, the downs, the unexpected twists and turns.
Exactly. It's a journey. And this time, that journey led them to a really important realization about how these antigens present themselves.
And who knows where that realization might take them next, right?
Who knows indeed. It's pretty amazing to think about, isn't it?
This research might even have implications beyond just blood transfusions, right?
It could. Think about JNU. It's still largely a mystery.
Right.
But finding those antibodies could revolutionize diagnostics and maybe even treatment for things we haven't even discovered yet.
Yeah. It's mind-blowing, really.
It is. It's a testament to the power of research, exploration. Sometimes the most valuable discoveries are the ones we weren't even looking for.
So even though they didn't find exactly what they set out for, they still pave the way for some really amazing discoveries.
Absolutely.
It makes you wonder what mysteries are hidden within that glycophorin B, right?
I know.
And what those secrets could unlock.
Lots to explore still.
Well, I guess we'll just have to wait and see what happens next. It's amazing, right? We started talking about one tiny antibody, and now we're talking about this whole protein and all the things it could mean for healthcare.
Yeah, it's really incredible how interconnected everything is in science.
Totally. It's like you said, pulling on one thread, and it's connected to this whole tapestry.
Exactly. It's a huge tapestry, and it's all part of this amazingly complex human body.
It really is. We've spent all this time talking about the challenges, trying to find those gene U and U antibodies.
Right.
But it's important to remember why this research even matters in the first place.
Oh, absolutely. For the people who don't have that U antigen, it's a really big deal. Blood transfusions, pregnancy, those can become really dangerous.
Yeah, it really highlights how important this kind of research can be, for people's lives.
For sure. And, it's not always the big discoveries that matter most. Sometimes it's understanding something like the structure of a protein. That can really make a difference.
Yeah, those smaller discoveries can have a huge ripple effect.
Exactly. It's not just about one antibody. It's about understanding how our bodies work on a deeper level. How does our immune system function? How can we use that knowledge to diagnose and treat diseases better?
So it's all about the bigger picture, scientific discovery, and how it can improve people's health.
That's it.
And like you said, it's not just about finding the answers. It's about asking the right questions, right?
Yeah, got to keep asking those questions.
Challenging assumptions and being open to those unexpected results.
Absolutely. Sometimes those are the most valuable findings.
Like with this scientist, They didn't find the antibody, but they realized something important about how that antigen is being presented.
Right. That could open up whole new areas of research that we never would have thought of otherwise.
It's really inspiring,
Yeah,
Makes me feel hopeful about what science can do in the future.
me too. There are so many more mysteries to unlock within the human body.
So many. Who knows? Maybe one day we'll come back to this story, Maybe that research into glycophorin B leads to some amazing new treatments or diagnostic tools.
That would be great.
And it all started with one scientist who wouldn't give up on finding that tiny little antibody.
It's pretty amazing when you think about it like that.
It is. Well, this has been an awesome deep dive. Thanks for joining me.
Thanks for having me.
And to everyone listening, until next time, keep exploring, keep asking those questions, and never lose that curiosity.